Define the term conductivity of a metallic wire with its SI unit. The definition of the conductivity we can define in terms of ratio. That is, reciprocal of resistance is what we call as conductivity with respect to its wire of unit length and its cross-sectional area. And it is denoted by the symbol sigma. So we can write this one as sigma is equal to 1 upon resistance. And the SI unit of conductivity is Siemens per meter or 1 upon ohms meter. Using the concept of free electrons in a conductor, derive the expression for the conductivity of a wire in terms of density and relaxation time. Hence, obtain the relation between current density and the applied electric field E. In order to find the relationship between the current density and the electric field, we are supposed to know the relations of a current, that is I is equal to, in terms of, that is I is equal to current, this relation in terms of number of free electrons and acceleration and the average drift velocity. That is I is equal to number of free electrons n and acceleration and average drift velocity, that is Vt, where n is the number of free electrons per unit volume, a is equal to the acceleration, and Vd is the average drift velocity. We know that acceleration A is equal to minus E divided by m, that is the electric field, and the average drift velocity, that is Vd, is equal to minus electron E and electric field upon m in terms of, that is tau. Okay, when we substitute this one, we will get the value I is equal to E, and minus symbol is there. If you are going to substitute, this becomes plus, and E square, I can write this one in terms of A only. A acceleration with respect to m and tau, and the electric field, that is the E, that is under the mod. And we also know the relationship between the current I with respect to the current density, that is we denoted by the symbol J. Okay, that is I is equal to mod of J with respect to acceleration. Then if you substitute these values here, then J is equal to mod of J is equal to I upon current upon acceleration. When substitute the values, that is E square A nu upon m with respect to electric field E, then divided by A is there. I will write as it is here, it is A. If I just cancel these two terms, then we get the answer, that is equal to, is also come, that is n E square tau divided by m. This is what we called as conductivity. Then the current density J is equal to, we can substitute this one in terms of conductivity, that is sigma into electric field, that is E. So this is the relationship between the current density and the electric field.